Hey chemists, I'm here with Chemistry Cat. I've recently decided to freeze myself to negative 273 degrees Celsius. My family thinks I'll die, but I think I'll be okay. Hmm, or is that 0 Kelvin? Hmm. Well, I hope you have accessed your notes on the combined gas law, and these are the last notes that we are covering for this school year. Hooray! The combined gas law is going to relate pressure, volume, and temperature, which is always in Kelvin, of a fixed amount of gas, a certain number of molecules of gas that doesn't change. If you happen to see STP, all that means is standard temperature and pressure. There's only one standard temperature, and that's 273 Kelvin. There are several standard pressures, though, and the ones we are going to be working with in the notes and in your worksheet are 101.3 kilopascals, which is equivalent to 1 atmosphere, which is equivalent to 14.7 pounds per square inch, which is equivalent to 760 millimeters of mercury. So these are your standard pressures that we are going to be working with today. Our formula, pressure 1 times volume 1 divided by temperature 1, equals pressure 2 times volume 2 divided by temperature 2. So you will be given 5 out of the 6 variables, and one of the variables you're not going to know what it is, and you'll have to rearrange the formula to solve for that unknown variable. So I hope you have a calculator handy. Here's our first example. A gas is collected in a 10-liter container at 50 degrees Celsius. The pressure is measured at 85.7 kilopascals. What volume would it occupy at standard conditions? Well, the very first thing that we need to do is list the given information. So 10 liters, what do you think that is representing? I hope you said volume 1. At 50 degrees Celsius. Here's our temperature 1. And we can't use Celsius, we need to put it into Kelvin. So we add 273. That gives us 323 Kelvin. Pressure is measured at 85.7 kPa. What volume would it occupy at standard conditions? So that's what we're solving for. Now, standard conditions. What is temperature at standard? I hope you said 273 Kelvin. And pressure too. Well, since we're working with kPa, kilopascals, what number goes with kPa for standard atmospheric pressure at sea level? 101.3 kPa. So there's our given information. The next thing we are going to do is write down the combined gas law formula. And here it is. Pressure 1 times volume 1 divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. So we are solving for volume 2. If you look at where volume 2 is, it's already in a numerator position, so we're just going to leave it alone. But we have to get it by itself. So what is happening between pressure 2 and volume 2? We're multiplying, right? So we have to undo multiplication by dividing by P2. So if P2 is in the numerator, we put it down here to divide it as a denominator, and what you do to one side of the equation, you do to the other. And pressure 2 cancels off here, and we've moved it effectively to the other side. Look at where temperature 2 is. We're dividing by temperature 2. So we have to put that in a numerator position and multiply by it. And what you do to one side of your equation, you have to do to the other. And temperature 2 cancels here. So now we've got volume 2 all by itself. So let's write our formula to solve for our unknown variable, V2, equals temperature 2 times pressure 1 times volume 1 divided by pressure 2 times temperature 1. And it doesn't matter the order of T2, P1, and V1 as long as those are in the numerator. And it doesn't matter if you've got T1 and then P2 down here in the denominator as long as both of them are in the denominator. So the next thing we're going to do is substitute the values in for our known variables. And we always want to include our units. Okay, so T2 is 273 Kelvin. Times pressure 1, 5.7 kilopascals, times volume 1, 10.0 liters, divided by, now this next step I want to tell you is extremely important. You're going to need a pair of parentheses in the denominator. Whenever you put this into your calculator, even if you don't put the parentheses in your work on your paper, that's okay. But when you put it into your calculator, you absolutely must be using parentheses. Otherwise, you're going to get the wrong answer. So pressure 2 on a 1.3 kilopascals times temperature 1, 323 Kelvin, and parenthesis. And now you can go ahead and put this into your calculator. So 273 times 85.7 times 10 divided by parenthesis 101.3 times 323 and parenthesis, and then you can get your equal sign. So here's what I got. 7.15 liters. How do I know it's liters? Well, Kelvin, Kelvin unit cancels. Kilopascal in the numerator cancels the kilopascal in the denominator. All that's left is a liter, and there we have it. So this is what I expect you guys to do. You're going to list the given. You're going to write the formula that you use to solve for your unknown variable. In this case, it was volume 2. You're going to show all your work with proper units, and you're going to answer with proper units. So let's move on to our second and last example. A weather balloon filled with helium occupies 4,572 liters at 18.6 degrees Celsius and 14.5 pounds per square inch. After it is released, it rises to a location where its volume increases to 5,198 liters and its pressure decreases to 11.3 pounds per square inch. What is the temperature in Celsius of the helium inside the balloon at this location? Well, we have a lot of information here. So here's our initial information: volume, temperature, and pressure. Here's our final volume and pressure, and we need to figure out what temperature in Celsius is our helium going to be in the balloon. Okay, so V1, P1, 18.6 Celsius, but we can't have it in Celsius. We have to convert it into Kelvin by adding 273. Even at the end, we're going to have to reconvert back into Celsius, but you have to follow the rules. Even if you try to solve this in Celsius and you don't convert it to Kelvin, you're going to wind up with the wrong answer in the end if you don't do this. Okay, so we get 291.6 Kelvin. Pressure 1 is 14.5 psi. Its volume increases to 5,198 liters. Its pressure decreases to 11.3 psi. And we need the temperature, the final temperature in Celsius. So here's our given information, all listed, very easy to locate. And our original formula, P1V1 . Okay, so here's our formula. Now we need to solve for temperature 2. Now look at where temperature 2 is. It's down in the numerator position. Well, it can't stay there. We have to move it into a, did I say numerator? It's denominator position. Look at where it's at. It is needing to be moved into numerator position on both sides, so it cancels here. Now that it's in the numerator position, I have to deal with all of this other stuff here, the P1, the V1, and the T1. So since P1 is on the top, I move it to the bottom. What I do to one side, I do to the other. P1 cancels here. V1 is on the top, I need to move it to the bottom. What I do to one side, I do to the other. Darn. There. Okay, so V1 will cancel here. And look at where T1 is. It's down here. I need to move it to the top. What I do to one side, I do to the other. I did that out of order, but you get the idea. And so my rearranged formula, temperature 2 equals pressure 2 times volume 2 times temperature 1 divided by pressure 1 times volume 1. Okay, so T2, that's my unknown variable that I need to solve for. I've got all of the known variables on the other side of the equation, and now we're ready to substitute the information in for those known variables. So pressure 2, 11.3 psi times volume 2, 5,198 liters times temperature 1, 291.6 Kelvin divided by. Hey, you remember what I said last time, how we have to use parentheses if you have more than one variable in the denominator? So 14.5 psi times volume 1, 4,572 liters, end parenthesis. So we're going to take 11.3 times 5,198 times 291.6 divided by parenthesis 14.5 times 4,572 and parenthesis. Now you can hit your equal sign. I get 258.4. Now what is my unit? Well, PSI cancels away, liter cancels away. Kelvin. Temperature is in Kelvin, but do I need it in Kelvin? No, I have to convert it into Celsius. How do I get it into Celsius? Well, to go from Celsius to Kelvin, I add 273. Go from Kelvin back to Celsius, I have to subtract 273. And this is going to give me a negative number. Negative 14.6 degrees Celsius. So that is my answer that I am after. Right there. So that is a cold temperature way up there in the atmosphere as this weather balloon has gone up, increased in volume, decreased in pressure and temperature. So this is what you're going to need to do for your worksheet. You've got 4 problems, and please follow the instructions. List the given information, include the units, rearrange your formula showing the formula to solve for the unknown variable, show your work with proper units, and give your answer with proper units. Don't forget, I still have office hours if you need to get a little extra help. Take care, everybody.